Week 5. This week we're focusing on decision making. You've done your analysis on identifying some symptoms and possible root cause, and so now it's time to evaluate possible solutions. Usually there's more than one way to solve a problem. So how do you decide which solution is the best one to propose? That's the point of what we're going to be talking about this week. I'm going to give you some examples of techniques that you can use to take some of the emotion out of decision making. And in fact, we're not going to cover all of it this week. We'll spill over into next week with some of the tools as well. So let's start first with risk. That's an important part when you consider the different options and alternatives that you have to choose from. How much risk is involved with each one of them? So your perspective on that risk relative to the gain or the benefit has a direct impact on how you make your decisions. Risk can be presented in different ways. You can have this dread, fear, where you have no control over the outcome, like with terrorism. Or you have the unknown. You just don't know what will actually happen. And the example I give there is GMO. We implemented genetically modified grain and other foods into our food source, and we really don't know. We did not do adequate studies and everything else. We have no way of knowing what the long-term effects of GMO are. And the other thing when you're thinking about the perception of risk is what affects it a lot is the magnitude of the potential risk. So if something has a small impact, it may not be a big deal. Who cares if it happens or not? If getting it wrong costs me $10, I can spare $10, no big deal. But if we're talking about $10,000, maybe it's a little, more important. So let's look at a couple of examples. The first one is, at the final seconds of the game, you've got, time for just one more play, that's it. The one play you could run, there's 95% chance of a tie score. The other play is a 30% chance of total victory. Which one do you choose? Or here we'll look at another example, maybe a little more, closer to home. You're very talented college student, you're finishing up, and you have two choices. You can go to medical school where there's an 80% chance that you're going to succeed and have a career and wealthy and enjoy all the benefits of that. But your passion is acting, where you have a 20% chance of success. Now, I would challenge that number and say that's overly optimistic. It might be closer to 0.2% chance of success, but in any case, you got two options. Which one is the better choice for you? So as you're looking at different possible solutions, the first thing you need to do is evaluate the risk. And one way you can do it is thinking of it this way: the negative impact or the consequences, the downside. Are they low, medium, or high? So the $10 would be down in the low here, 10,000 up in the high. But then also, how likely is it to happen? Is it very likely to happen, or is it highly unlikely? And what the boxes that are filled in here show that in those areas, it's not such a risky option to go with. Even if the negative impact is high, if it's highly unlikely to happen, then maybe that's not so risky. Now the flip side is, I'm going to fill in with the orange blocks here. Those are areas where you would say this is a risky situation. Those are the ones you need to pay a special attention to. And so framing your solutions in the possible outcomes, part of that is evaluating the risk. How risky approach is this if you're going with it? Obviously, things like nuclear war, a huge impact, but we hope the likelihood is very unlikely. And so is it risky? Not as much as it was back, say, in the Cold War years, the late 60s. Asteroid striking the Earth. Again, another one where the likelihood of it happening, pretty slim, but if it does, whoa, that's going to be the end of a lot of things. But again, because it's so unlikely to happen, certainly in our lifetime, there's not much risk there. So to make a decision, what we want to do is to get out of the emotional, gut level, personal bias, and instead use some objective criteria, some rational way that you can make a decision, and so that you can communicate to others, how you got to that decision, so they can look at it and say, yeah, I see, and I agree with that. We need to get it out of that opinion-based decision making. So here's some tools, that are commonly used in business and in your personal life to make decisions. And we're going to go through them and go into them a little bit more so that make sure that you understand the basics of how they are and how they function. So let's take an example. We have a decision to make. We have a heat pump and it's broken. So we can obviously, the first thing is let's get it fixed. Okay, $1,500. But, this has got a lot of years on it. Maybe we should think about replacing it. Okay, so how much does it cost to replace it? Yow, $12,500. Big difference. Which one is the better approach? Well, let's look at how we could use some of these tools, one of these tools, to help us make a decision. So the first, we're going to look at a weighted matrix example for this one. And you start first with an analysis of the situation. Write down all the facts, everything you know. Okay, it was installed in 2000. It's got a lot of years on it. New heat pumps are more efficient than the old ones. Oh, that means I would use less electricity. The new heat pumps use Puron instead of Freon. Freon, was a problem with the ozone layer. Puron is not as much. So that's kind of a nice thing that it's using something that is more environmentally friendly. I'd love to use natural gas for my heating, but it's not available in my neighborhood, so I really do need to stay with the heat pump. That old heat pump, 19 years old. Wow. How much is it going to cost each year? Is this just the beginning? Is next year, is it going to cost $3,000? And after the year after that, $5,000? I don't know. So now let's put together some evaluation criteria. Let's look at short-term financial impact. Yeah, I've got savings, but, I need to know how much it's going to cost me right now. Long-term financial impact. Yeah, we should always be considering that down the road, what things costing me. Energy efficiency, absolutely. I'm all for being more energy efficient. Peace of mind. Now here's an important one. Sometimes this gets overlooked. It's not just about dollars and cents. You can get the most cost-effective solution, but if you're nervous about it and you can't sleep at night, peace of mind is worth something. So let's include that in our analysis. And the air filtration capability. Well, the newer units do a better job. So let's see. What we're going to do now is we had that list of criteria, and we're going to assign each of them a relative factor. So how important are they? And the key here is that when you add up all of the weighting factors for all of the criteria, it has to total 1. So for each of the criteria, you're going to be entering in things like 0.1, 0.15, 0.3, as long as the total then adds up to 1. Then the next thing you're going to do is rate the criteria for each of the solutions, how well that solution addresses that criteria. And you'll see in the example what I mean by that. So you're going from a scale of 1, meaning it really doesn't meet the criteria very well, to 10, it does perfect. And then you multiply that rating that you just gave that criteria by the weight of that criteria. And once you have that multiplied, you add them all up. And this will be clear when we look at the example coming up. You'll see in the spreadsheet what I'm talking about. And that becomes really easy. Whichever of the options has the highest score based on a weighted matrix procedure is the best solution. So we start by listing all 5 of the criteria that we came up with. Now you could have more than that. You could have 10, 12. This is just for illustrations. And we're going to decide how important each of those criteria are, how important each one is in the total overall decision making process. Criteria are not equal. Some are more important than others. So let's fill it in. We said short-term cost, we give it a 0.25. That's because I have some savings, but I don't want to spend a lot short-term. Long-term is not so much. I give it a 0.1 because I can budget for long-term stuff. Peace of mind. In this case, we rated it at 0.3. We actually rated peace of mind as the highest of the criteria in this example. And you'll notice that when you add all of those up, it equals 1. Now, the next thing we're going to do is evaluate the first possible solution, buying a new heat pump. Well, short-term cost, not so good. That's a lot of pocket change. So it gets a 1. Long-term, however, it's brand new, so I don't expect to have any significant costs associated with it for years to come. So that does a good job. That's a 9. Energy efficiency, we already said it's more efficient. So looking at the specs on the original unit and the new unit, I'm going to give that a 7. Peace of mind, though. Hey, that's a 10. Because I know this thing's not going to break down. And if it does break down, I got warranty, so no sweat. I'm very comfortable with that. And it's got a better air filtration, so we'll give it an 8. Now we do the same thing with fixing the existing one. Well, short-term cost, $1,500 is not too bad. I can handle that, so I give it an 8. Long-term cost, I have no idea. This could be the beginning of this breaking, that breaking, all the time, constant repairs. So I'm giving it a 2 because it could be a money pit. Energy efficiency, I know it's not efficient compared to the new one, so it only gets a 3. And the peace of mind, that's really that uncertainty. I don't know when this thing is going to break next. Is it going to break right before the cold spell, hits, and I have no heat for days while they're ordering in parts? That doesn't give me much peace of mind. So it gets a 1. And we know it didn't have a good air filtration system, so it gets a 2. Now we're going to multiply. So we take each criteria, the weighting at 0.25 for short-term cost, buying a new one, then 1 times 0.25 is 0.25, fixing is 2.5 times 8, which is 2. And then you do that for each of the criteria down all the way, filling in the numbers, and then you just simply add them up. And you'll notice right away that buying a new one had a much higher resulting number than fixing the existing one. And a lot of that's driven by that peace of mind element of it. So this is a tool where it can take some of the emotion out of it and instead show you that in this case, your overall, based on the criteria you defined and the weighting you assigned, that this is a better solution. This works well where there's a big difference between the numbers. If we had 5 possible solutions here and they all came out as to being 5, 5.2, 4.9, 5.1, really clustered close together, then it doesn't help you make a decision. In that case, what you would want to do is go back to your criteria and add in some additional criteria, relook at that, make sure that you've picked all the appropriate criteria, and relook at your weighting to make sure that you agree that that is the appropriate weighting. Another way you can do it, this is kind of a nice one. Alternatives table. Doesn't require any math. All it says is tabulate all the alternatives into a single table that you can look at on one piece of paper. So here we have 4 jobs. And we've got 4 criteria. We could add in, some more criteria. But they're all right together. And what you want to do when you're looking at it is usually when you have multiple alternatives like this, 1 or 2 of them are going to jump out right away as not being very attractive. So you can discard those and before you do anything else. So this is a tool that allows you to whittle down when you have a large number of alternatives to just a few to look at in more depth. So in this case, for example, job 1, 38,000 bucks. Oh, I like the 38 hours a week, but 38,000 is just not enough. I got to make more than that. No, I'm going to toss it. I'm not going to go that route. Job number 4. Well, salary's nicer. I like the 46,000, but 60 plus hours a week and with a lot of intense travel? No, thank you. So we can toss out job 1 and 4, leaving us to focus on job 2 and 3, which now we could go back to our weighted criteria matrix with job 2 and 3 and really zero in on. Because there's no point spending a lot of time analyzing job 1 or job 4 if they really aren't going to be contenders. So a lot of times we do this kind of subconsciously as we're looking at different solutions, but this is really helpful when we put it down on paper. Then we know, why did I reject that job? Oh yeah, that's right. This was because of the salary. Trade-off table is a similar approach where we're just going to look at, alternative A versus alternative B. What are the results? Again, it's just a way of concisely displaying the alternatives, and this allows you to, again, to assess and to see what looks like an attractive proposal that you want to dig deeper into. You'll notice the big difference between a trade-off table and the previous alternatives table. On the alternatives table, we have the options, the alternatives along the top and the criteria along the left side. Where in a trade-off table, we have the alternatives on the left and the different criteria along the top. So it's really just 2 different ways of displaying kind of the same information. This one's an interesting one. And this works well at the beginning when you're trying to do some filtering out of possible solutions. Just take the proposed solution and write down all the positive things you can think about that solution. Just write them down all, when you've got them all down, then go back and rate each one on a score of 1 to 10. How much of a positive is that? If it's, well, it's an okay, it's not fantastic, but it's okay, then maybe it gets a 5. But if you say, wow, this would be, this is a really big deal, this is a really important, positive, then it'd get a 10. And then likewise, you do that with all the negatives, is just write down all the negatives you can think about that. And again, rate them from 1 to 10 as to how negative they are. And in that case, you're rating them on a minus scale. So minus 10 is really, really negative from your perspective. Let's say you hate to travel, and especially you hate to fly, and so you're looking at that example before where the one job had a lot of intense travel, and so you would have down there a negative item that you've listed is extensive travel, minus 10. And then what you do is you add up all the positives and the negatives and look for a net score. If it's positive, then that tells you that that particular solution has an overall positive, you're viewing it in a positive manner. And this can be useful when looking at different alternatives, again, for comparing them. You look at, wow, this one, I ended up with a plus 35 when I added everything all up. This one was a plus 15. Not nearly as positive. And wow, this one's a minus 25. Well, I guess I don't need to consider that. So again, it's a tool you can use to narrow down the options that you want to look at really seriously. Paired comparison is used when you're in a team environment. As shown here, what you do is you have individuals come up with their own ratings, and then you come up with the team total as to what the team was saying. In this case, the team looks like the consensus is that sell is the correct one to do for that. So again, it's the idea that you can take and tabulate what everyone has put in and then look at it as a team and look and see, okay, this is what we seem to be saying. Does everyone agree that, yeah, this is the way we should go? Okay, at this point, I'll stop with the password for this week's quiz. Decision tree. And we will actually cover decision tree in the next slide. Okay, let's talk about decision trees. Again, this is just a graphical way of trying to capture information that helps you visualize and see which solution is going to be the best for you. So we have one option where we stay in-house, doesn't impact jobs, but we don't develop new products, or the other option, we outsource it, that increases the unit cost, and we may lose some jobs, but we're able to get more products developed. And then we look at what happens when demand increases. And we're saying the demand increase, there's an 80% probability it's going to increase. And there's only a 20% probability it's going to decrease. Down on this option, we're looking at demand increases 50, demand decreases 50. And then we have some dollar amounts associated with those different ones. So again, as you see, again, this is just a real high level overview of this. You can see how this can graphically help us to see the difference and say, gee, I've got an 80% probability up here and losing $1 million. Down here, I've only got a 50% probability of losing 500K. And so kind of starts directing you to where you think, gee, which one do you feel more comfortable with? Again, graphics are very helpful. This is a flow chart. You put together a flow chart, decision tree. Anytime you can express something graphically, it can help you identify what solution appears to be better in your situation. It doesn't have to be nice and pretty. It can be really, like this, drawn on a flip chart. You can draw it on a whiteboard, take a picture of it with your smartphone, and a lot of it is when you try and map something out like that, the process of doing that forces you to ask the questions that are necessary. And just the process of creating a chart like this oftentimes will point you in the right direction, and you'll see, there's the solution. It's obvious when you map it out. That's week 5. So again, if you have any questions about this week's assignment, be sure and get in touch with me.